previous lessons, we looked at the three primary views in orthographic drawing. These are referred to as the three primary views because they are the most useful generally in describing the faces of an object we're trying to make. These views being the front view, the right side view, and the top view. For most objects, these three primary views will suffice in giving us all the information needed when attempting to build an object. However, there are times when additional views are required. One such additional view is known as the auxiliary view. This view is most often used when describing an object that has an inclined or diagonal face, such as the object I've drawn here. Usually, when creating our orthographic drawings, we've divided our drawing plane into 4 quadrants. This is a useful technique when learning to draw orthographic projections. However, it's not a necessary step, and in fact, in most professional environments, you won't find people breaking their drawing plane into these 4 quadrants. When we begin considering ways in which we want to lay out our drawings, we should consider the object which we're attempting to depict. What views will be necessary to show the details needed? Will we need a back view, a bottom view? Will we need a cross-section view, or will we need an auxiliary view? For this drawing, the space in the center of our drawing plane will be needed to create our 4th auxiliary view. It's important to know and understand when the auxiliary view is necessary. Let's go ahead and consider our isometric shape. This entire side of the isometric shape is composed of this inclined diagonal face. I'm going to go ahead and color it in for you here. And as you can see, this makes up a rather large surface on the object which we are attempting to depict in our drawing here. So let's see how that's represented so far in our drawing. Well, from the front view, we have an accurate length, but from the side view and from the top view, here I'll get my ruler to show you, this length is not accurately represented. And this would apply to all shapes and dimensions that fall along this inclined plane. So here, this is 2 inches and it's about 1.5 inches in either of these views. And that's just this side. If there was a circular cutout hole, the circular hole would look like an oval, like a squished circle. If there was a square cutout or a square shape, it would appear like a squished rectangle. This type of distortion is what's known as foreshortening. And in order to avoid any sort of distortion in our technical drawing, we want to have a view which accurately depicts all of this detail. In order to have a view in which none of the detail is distorted, we need to create a plane in which our line of sight is perpendicular to the face of the object we're trying to depict. Let's examine this visual representation of these 4 views. So here we have the front view, the right side view, and the top view. All of these views are perpendicular to each of those sides. If we were to draw projector lines, they would extend in a perpendicular direction from this face. This is what we are attempting to replicate when we create the auxiliary view in our drawing. So let's go back to our drawing and consider how we might do that. If we look at the angle of the inclined plane, we can see that it's inclined at a 45-degree angle to the left. We know it's a 45-degree angle because the line bisects the square cells of our graph paper diagonally from corner to corner. And a square's corner is 90 degrees, therefore a line that bisects that corner equally would be a 45-degree line. So let's draw a line that extends 45 degrees in the other direction, which would be perpendicular to the face of this object. this is going to be our 45-degree projector line, which creates the dimensions for our auxiliary view. And just like we did when we projected this same information horizontally to create our right side view, we must now project this information diagonally along this 45-degree angle to create our auxiliary view. You may recall in previous lessons, I have explained that you must use projector lines to transfer information from one view to the other. So from the front view to the right side view, or to the top view, we must always use projection lines. So while it may seem simpler just to remeasure and redraw each view individually, we must use projector lines. And this is exactly why. It's impossible to do this without projector lines for the auxiliary view. We have to use projector lines to get correct dimensions. Later in the drawing, you'll see where I failed to project important information from the front view to the auxiliary view, and it creates an incorrect dimension. So now that I've boxed in the height with these projector lines, just as we did in every other view, I want to box in the width. So I'm going to pick the widest point on the drawing and draw those dimensions to sort of box in my shape. So I just pick a spot somewhere on my drawing plane that's clear and gives me enough space, and I draw a 45-degree angle uh, inclining to the left, and it's running parallel to the face of the object which I'm trying to depict. And now I need to figure out how wide to draw the other side of my box. So I need to actually measure this dimension. I can't just count the cells diagonally, because the diagonal length from corner to corner is longer than the length of the cells from along the sides. So yeah, I'll measure the length, and it is 1.25 inches. So I'll make a couple dots along the projector lines to make sure the line I draw is perfectly straight and parallel to the other line of my box. And this is the width boxed in for my auxiliary view. Okay. Remember when I said it's important to project all information and not just measure it and redraw? Well, I just measured a vertical measurement for the lower part of this backwards L. And as we know, in the right side view, all vertical dimensions are distorted. It's not as tall as it should be. It's been squished. So this measurement I'm making here for the lower part of this L is a distorted measurement. Obviously the width's not distorted, but all height information is distorted. So I can measure this width to know how wide the top part of this L is, because that's not distorted. It's not squished that way. And you'll see it creates an incorrect dimension because I did not project all necessary information. I'll correct it, of course, but I want to show you what that looks like. So I make a couple dots and ensure that my line I'm drawing is parallel. That was a little off, I could tell, so I'm going to just remeasure and draw that dot again. Again, make two dots at the top and bottom to ensure you're drawing a parallel line. That looks a bit better. This is necessary when we're working off the grid. Okay, and now I think I have my object fully boxed in with correct dimensions, which I do not. I'm about to realize it. So I begin blocking in my auxiliary view with visible lines. And as I draw this line, I realize that does not look right. And here's why. I needed to project that line from the corresponding point at 45 degrees. See how much longer this shape should be? Here we go. That is the correct dimension. So now I can go in and block in this shape, and I'll have it accurately dimensioned auxiliary view. So I hope you've enjoyed this lesson on auxiliary views. As you can see, everything we learn builds on each other to help us draw more and more accurate drawings. If we had not learned how to draw objects with unknown angles, it would be impossible to draw that first front view with that inclined plane. And now we know how to accurately draw all the details on the face of that inclined plane with the auxiliary view. So that's going to do it for this lesson. See you in the next one.